This video will discuss on the overvoltage relay, or another name is overvoltage protection. Overvoltage is a condition which could happen in a generating system in the event of a fault in the field excitation circuit. For example, internal grounding of the field winding or an open circuit in the voltage regulator sensing line. Devices are therefore necessary to protect consumer equipment against voltage higher than those at which they are normally designed to operate. The method adopt varying between aircraft system and also on whether they supply DC or AC. Okay, in this video we'll discuss on the example of overvoltage relay apply on type of DC system as shown in this figure. Okay, as said here, if voltage exceeded preset level, the latch relay is stripped and take the generator offline. Okay, the time taken for the relay to trip is inversely proportional to the value of over voltage. The higher the voltage, the faster it will trip. The trip caused by over voltage must be manually reset. Okay, no example here, generator will trip if output voltage rise more than 32 volts. Here, example of the overvoltage protection for DC generating system. So here we have the DC generator. This is the armature, and this is the field coil. Okay, and this is the overvoltage relay. Consists of the sensing coil and resistor. This is the voltage regulator. This is a carbon pile type of voltage regulator. Okay, and also the contactor that will open or close to connect the power from the generator to the bus bar. Okay, again here the relay consists of a numbers of contacts. For example, here we have 3 contacts connected in all the essential circuit of the generator system and mechanically coupled to a latching mechanism. This is the latch. Okay, this mechanism is electromagnetically controlled by a sensing coil and armature assembly. The coil being connected in the generator shunt field circuit and in series with the resistor. Okay, you can see here the coil is connected in series with the shunt field and also in series with the resistor. Okay, depending on the Ohm's law, V equals to IR or R equals to V over I, the resistance of which decrease as the current through it is increased. As current become higher, the resistance become lesser. Okay, under normal condition, okay, normal condition, for example here 28 volts. Okay, under normal regulated voltage condition, the sensing coil circuit resistance, the sensing coil circuit resistance, where is the cursor? Here. The sensing coil circuit resistance is high enough to prevent the generator shunt field current from releasing the relay latch mechanism, and so the contact remain closed and the generator remain connected to the bus bar. Okay, you can see output of the generator will go to this contact as it is normally closed, supplying to the carbon pile of water regulator, to the relay, and also to the shunt field. If there is a high voltage, the carbon pile, at the same time, the output of the armature will go to the carbon pile and to the voltage coil. Okay, this is used to sense the voltage of the generator. If the voltage higher, the carbon pile will decompress and resistance increase and reduce the current flow through the field and also to this one. As the current flow to this relay, it will close the line contactor and allow the current to flow from the generator to the bus bar. Okay, normal operation, whatever goes to the shunt field will also go to the sensing coil and resistor into ground. Okay, our voltage will detect if the voltage is higher than 32. But now the voltage of the generator is about 28. So whatever goes here will go to the sensing coil. If Now they are energized, but it's not energized enough to pull the latch here, since 28 is smaller than 32. Okay, if however, if there is an open circuit, if let's say open circuit in this voltage coil, okay, an open circuit occur in the voltage regulator coil sensing line, the shunt field current increase, and because of the inversely characteristic of the relay sensing coil resistor, the electromagnetic field set up by the coil cause the latch mechanism to release and a relay, okay, contact to the open position, thereby isolating the system from the bus bar. Let's say, uh, again, if there's open here, so the sensing coil cannot sense the output of generator to, if higher voltage, this one will be decompressed. Let's see something happen here, open circuit current cannot flow to this voltage coil, so the current continues to this carbon pile. The carbon pile is not moving since this voltage coil is not sensing any higher voltage output from the armature. So the output will keep increase, okay, and go here to the coil. At the same time, it will go back to this sensing coil. When the sensing coil, a high current flow through the sensing coil, it will energize enough to pull this thing and open the relay. Okay, let's see. Okay, here 32. Okay, once it become energized, okay, pull all the contact will open, and therefore the output of data cannot go through the bus bar as this contact is open. Once all this contact open, current cannot supply to this coil, to the line contactor. When no current to this line, therefore the relay is not energized, it will not close this line contactor. Okay, that's all for over voltage protection.